A curve with path through 0, 3 has equation y equals to fx. It is given that f prime x equals 2, 1 minus 2, x minus 1 cubed. Find the equation of the curve. To find the equation of the curve, we have to integrate this form because this is f prime x. We know that this is dy dx. So dy dx is 1 minus 2 x minus 1 to the power of negative 3. So y is integral of this function with respect to x, and this becomes x minus 2 x minus 1 to the power of negative 2, and then we divide by negative 2 plus c. So x plus x minus 1 minus 2 plus c. So this is the equation. And then we have to find c by replacing the coordinates 0, 3. So 3 equals to 0 plus 0 minus 1 negative 2 plus c. So 3 equals to 1 plus c. C equals to 2. So that means the equation will be x plus 1 over x minus 1 square plus 2. That's for number 1. A. The tangent to the curve at 0, 3 intersect the curve again at one point P. Show that the x coordinate of P satisfies this equation. Okay, if they said the tangent intersect the curve, so we have to find the intersection point. The intersection point is P. Therefore, we have to find the equation of the tangent first, yeah? So to find the equation of the tangent, we need the gradient. So we can use the dy dx equals to 1 minus 2 over x minus 1 cube. Yeah, we check 1 minus 2 x minus 1 cube. Yeah, correct. So we replace the coordinates x equals to 0. So the dy dx will be equals to 1 minus 2, 0 minus 1 cube is negative 1. So 1 minus 2 over negative 1. So 1 plus 2 equals to 3. So the gradient is 3, and the equation is y equals to mx plus c. So 3x plus c, replacing the coordinates 0, 3. So 3 equals to 3, 0 plus c. So c equals to 3. So y equals to 3x plus 3. This is the equation of the tangent. And then to find the intersection point, we have to equalize with the equation of the curve. The equation of the curve is this: y equals to x plus 1 over x minus 2 square. So y equals to x plus 1 over x minus 1 square plus 2. Yeah, correct. Plus 2. And we have to equalize. So 3x plus 3 equals to x plus 1 over x minus 1 square plus 2. So simplify into 2x minus 1 over x minus 1 square plus 1 equals to 0. And then we want to make it into this. So we can multiply it by x minus 1 square. So 2x, x minus 1 square, minus 1, plus x minus 1 square equals to 0. And then so we can simplify. I rearrange plus x minus 1 square minus 1. And I can factorize this. X minus 1 square to x plus 1 minus 1 equals to 0. And this is the same, yeah? Shown. And then verify that x equals to 3 over 2 satisfies this equation, and hence find the y coordinates of P. So verify that we can substitute the x equals to 3 over 2. So 3 over 2 minus 1 square, 2 times 3 over 2 plus 1 minus 1. So this is equals to 1 over 2 square, 3 plus 1 minus 1. So 1 over 4 times 4 minus 1 equals to 0. Yeah, correct? And hence finds the y coordinates of P. So we can just put the x 3 over 2 to the equation. The equation, we can use the equation of the line, yeah? Y equals to 3x plus 3. So it's 3 times 3 over 2 plus 3. So 9 over 2 plus 3 equals to 9 plus 6, 15 over 2. So the y coordinate will be 15 over 2. Second, solve the equation for sine theta plus tangent theta equals to 0. So we have to change the sine, the tangent into sine theta over cos theta equals to 0. And then make the denominator the same. Equals to 0. This is over cos. And then I can just cos multiply. So I have for sine theta, cos theta plus sine theta equals to 0. And then I can factorize sine theta. So for cos theta plus 1 equals to 0. So sine theta will be equals to 0, or cos theta will be equals to 1 negative 1 over 4. So for sine theta equals to 0, we will have it theta equals to 0, or it can be 180. Yeah, we know that sine 0 and 180. And then for cos negative 1 over 4, it will be in the second quadrant and third quadrant. But since the theta only between 0 and 180, so we only take the second quadrant. And the result for the cos inverse, so theta is cos inverse 1 over 4. In second quadrant is 180 minus 75.5. So 104.5 degree. So there are three answers. The answers are 0, 104.5, and 180 degree. But we see here it's not inclusive. So the answer should be only the middle one. So the answer should be only 104.5. So the 0 ignored. That's it. Number 3. A curve has equation y equals to ax half minus 2x, where x greater than 0 and a is constant. The curve has stationary point at point P, which has x coordinate 9. Find the y coordinate of P. So we have to find the a. From this stationary point, we can have from dy dx equals to 0. So first we have to find the dy dx. The dy dx of this is half ax minus half minus 2 equals to 0. And then we can put the x equals to 9. So half a, 9 minus half equals to 2. So this is 1 over 3, a equals to 4. So a equals to 12. So from here, I can find y equals to 12x half minus 2x. And then put the x coordinate again. Y equals to 12, 9 half minus 2 times 9 equals to times 3 minus 18. So 36 minus 18 equals to 18. That's number 3. Number 4. Number 4, the diagram shows the circle and the straight line intersecting at point A and B. The point D is on the x-axis such that AD is perpendicular to the x-axis. Find the coordinates of A. The coordinate of A will be the intersection between the circle and the line. So we can find the intersection by equalize the equation. I can substitute y equals to 2x minus 1 to the equation of the circle. So x squared plus y squared equals to 2. And then replace the y to x minus 1 squared equals to 2. So expand x squared plus 4x squared minus 4x plus 1 equals to 2. So 5x squared minus 4x minus 1 equals to 0. So 5x, x, 1 and 1, minus 5, and then plus 1. So x equals to negative 1 over 5, or x equals to 1. So there are two solutions. So that means the first one, the negative 1 over 5, will be the coordinate of P. So x equals to negative 1 over 5. And the x equals to 1 will be the answer for A. So the coordinate of A will be y equals to, we can just put it to the formula, 2x minus 1, so equals to 1. So coordinate A will be 1, 1. That's it. Find the volume of the revolution when the shaded region is rotated around x-axis, give your answer in the form of pi over a b root c minus d, where a, b, c, d are integers. So we have to rotate the region 360 degrees about the x-axis. So we rotate this from here, x equals to 1. The circle here has the radius of root 2. So that means the boundaries here will be equals to square root of 2. Yeah, because the radius is square root of 2. So we rotate the circle from 1 until root 2. So x squared plus y squared equals to 2. So y squared equals to 2 minus x squared. And the volume will be equals to pi integral y squared dx, because this is rotated about x-axis from 1 until root 2. So in here, pi integral 1 square root 2, 2 minus x squared dx. So pi, so this is x, 2x here, minus 1 over 3x cubed, 1 until root 2. So pi, 2 times root 2 minus 1, minus 1 over 3, root 2 cubed minus 1 cubed. So this is pi. I will have 2 root 2 minus 2 minus 2 over 3 root 2 plus 1 over 3. So equals to pi. I can combine 2 root 2 minus 2 over 3 root 2, and then minus, this is 6, so minus 5 over 3. So equals to pi 4 over 3 root 2 minus 5 over 3. So pi over 3 for root 2 minus 5. Yeah. And then for C, find the exact expression for the perimeter of the shaded region. So the shaded region, we have to find arc AD. Oh, there's no name here. So I can say this P. So find the arc AP, and then find DP, and find AD. We know that the coordinate of A is 1, 1. So that means this will be 1. And dp will be root 2 minus 1. So that means for the perimeter, we have to find AP first. AP is the sector of OAP. And to find the arc length, AP, this is A, this is O, this is D. This is 1, this is root 2, this is 1. So we can find the theta first. So the theta can be taken by tangent. Theta equals to 1 over 1. Yeah, because this is 1. So that means the tangent will be equals to pi over 4 radian. And then that means we can find the arc AP using the formula arc theta. So r, the radius, is square root of 2 times theta pi over 4. So root 2 over 4 pi. That's for the arc AP. So the perimeter is AD 1 plus arc AP root 2 over 4 pi, and then plus dp. dp is root 2 minus 1. So that means I can find the exact expression, yeah? So 1 and minus 1 cancel. So 1 over 4 root 2 plus 1 plus root 2, that's it. Number 5. Curve with equation intersect at A, B, as shown in the diagram. Find the area of the region between the two curves. So that means we will find this area. So we can find using the integration, area is integral from the intersection point 0 until 4. So 0 until 4. The first equation, 2x half plus 1, minus the second equation, half x squared minus x plus 1 dx. So we can simplify it first, yeah? So this is 2x half, and then minus half x squared plus x minus 1 plus 1, so 0 dx. So equals to, this is x to the power of 3 over 2, so 4 over 3, minus 1 over 6 x cubed plus 1 x over 2 x squared, 0 until 4. So equals to 4 over 3, 4 over 3 over 2 minus 0, minus 1 over 6, 4 cube minus 0 cube, plus 1 over 2, 4 square minus 0 square. Yeah, this is 3 over 2. They are the same, it's 0. So 4 to the power of 3 over 2 is 8. So 32 over 3 minus 4 over 4 cube is 64. So 64 over 6. I can simplify this into divided by 2, 32 over 3. And then plus 4 square is 16. 8. 8, yeah? So the area is 8. The acute angle between the two tangents at B is denoted by alpha, and the scales on the axis are the same. Find alpha. So it says that the tangent on both curve make an angle of alpha at point B, 4, 5. So we have to find the tangent using the first derivative. So the first one is y equals to 2x half plus 1. So y equals to 2x half plus 1. And the other one is half x squared minus x plus 1. Half x squared minus x plus 1, 2x half plus 1. Yeah, correct, yeah? So we have to find the derivative first. So this is x, negative 1 over 2. This one, x minus 1. So the gradient when x equals to 4 is equals to 1 over root 4. So 1 over 2. And this one, the gradient is 3. So that means from here, we can find the angle, as we know that the gradient equals to y over x, rise over run, and this is equals to tangent theta. So I can find the angle constructed by all of the gradients to the x-axis. So for the first one, the gradient is half. So that means tangent theta 1 equals to half. So the theta 1 should be equals to degree, yeah? So tangent half of degree, tangent inverse of half, 26.57 degree. And then for the second one, tangent theta 2 will be equals to 3. So theta 2 will be, tangent inverse of 3 is 71.56. So that means the alpha will be the angle. So if we compare this, so this will be theta 1 and this will be theta 2. So alpha will be theta 2 minus theta 1. So minus 26.57. So 45 degree. Yeah, that's the angle between the two tangents. Next, number 6. The diagram shows triangle ABC with AB equals to BC. So this is equal, yeah? An angle ABC 1.8 radian. The arc CD is part of the circle, center A. ABD is a straight line. Find the perimeter of the shaded region. So the perimeter of the shaded region, we have to find the length of CD, BC, and BD. First, we know that ABC is an isosceles triangle. So we can find the angle here. the angle BAC will be equals to pi minus 1.8 and then divide by 2. It's pi minus 1.8 divided by 2, 0.671 radian. And from that, we can find the length of DC, arc DC. You see the formula, arc theta. So the radius is AC and AD, but we don't know yet. So we have to find AC first. So we have to find AC. We can find using the cosine rule. AC square equals to 6 square plus 6 square minus 2 times 6 cos 1.8. So this is 6 square plus 6 square minus 2 times 36 cos 1.8. So this is 88.36. So AC will be equals to 9.399, 9.40. So this is the radius. So I can put 9.399 times the theta. The theta will be the angle A here. So 0.671 equals to 6.31 centimeter, yeah? And then we have to find dB. So dB is equals to 9.399 minus 6. So this is 3.399. So the perimeter, that means the perimeter is equals to BC 6 plus DB 399 plus R DC 631. So equals to 15.71 centimeter. That's A. And B, find the area of the shaded region. So we can find the sector area using the formula half R squared theta. The R is 9399 square times 0.671. So this equals to 9.399 square divided by 2 times 0.671. So this is 29.64. And then the area of the triangle is half times 6 times 6 sine 1.8. So this is 17.53. So the shaded area equals to 29.64 minus 17.53, 12.1 centimeter square. I think this is the last question. Prove the identity. So from the left hand side, sine cube theta over sine theta minus 1. So I multiply this by 1 plus sine theta, 1 plus sine theta, minus sine square theta, 1 plus sine theta, times with sine theta minus 1. So this is equals to sine cube theta plus sine 4 theta over the denominator will be sine theta plus sine square theta minus 1 minus sine theta. So this one cancel. And this one is sine cube theta plus sine square theta. So I can cancel this. So equals to sine 4 theta plus sine square theta over sine square theta minus 1. So from here I can factorize the sine square theta, sine square theta plus 1, and this one is sine square theta minus 1. So from here I can write as sine square theta minus 1 can be written in the form of negative cos square theta. Yeah, don't forget the identity. 1 minus sine square theta equals to cos square theta. So that means sine square theta minus 1 is equals to minus cos square theta. So sine square minus 1 equals to negative cos square. So this is sine square theta plus 1. So I can make it into negative tangent square theta sine square theta plus 1 equals to right hand side. Hence, solve the equation. Okay, what's the difference? The difference is only the right hand side, yeah? So that means I can rewrite the left hand side using our results, yeah, for B. So this is negative tan square theta sine square theta plus 1 equals to the right side tan square theta and then 1 minus sine square theta. In this question, don't change 1 minus sine square theta into cos square theta because it will make it complicated. So the one that we can do here is rearrange the expressions, yeah? Don't cross the tangent square theta because you will remove the possibilities of answer. So we can expand first. Tangent square theta sine square theta minus tangent square theta equals to tangent square theta minus tangent square theta sine square theta. So from here, this one can be cancelled out because of plus and minus. So I will have 2 tangent square theta equals to 0. So that means tangent square theta equals to 0. So tangent theta equals to 0. And theta 0 is when theta equals to 0 or theta equals to 180 degree. Is this radian or degree? Oh, radian. So it's only pi. So since we cannot take the 0, yeah, so the answer should be theta equals to pi only. I think that's all for this question and for this worksheet. Thank you. Bye.